Hey guys, so I'm gonna make a quick little video going over two of our true heated, high humidity, high flow systems. All right. Typically, you're gonna hear these kind of the brand names, slang word kind of going around as Optiflow or Airvo. So I'm gonna show you. I'm gonna do two separate videos. I'm gonna do one on the Optiflow here first. Okay, and then I'm gonna do a separate one for the Airvo. So I'm going to show you this particular device. I want you to realize that once again, this is something that I made. All right. A lot of respiratory departments have these devices, which is ultimately, let me move that out of the way just a little bit here. This is an old air oxygen blender. Okay. A lot of our older ventilators before they had digital blenders utilize stuff like this. So when I came here at Forest Park, I wanted an Optiflow. I rummaged through our supply room and found a blender, and I built this. Okay, so it's a little bit different than what you might see. You can see I have a blender here that ultimately has 250 psi gas sources. Okay, I have high pressure air tubing and oxygen tubing. All right, I'm going to introduce you to a common alarm that kind of take place. Okay, and that's a blender alarm. So if something happens and I lose one of my 50 psi sources, as I'm going to show you here, it's going to make a very distinct alarm noise. You're going to also hear a ventilator alarm here in a second. Hang on. Let's try to avoid the ventilator from alarming. Okay, so I'm going to plug in my air connection, and you can hear that loud whistle. It means I don't have one of my 50 psi sources. So I'm all hooked up and ready to go here. Okay, so I got my blender, and it's hard to see in this video, but ultimately there's a little knob, and it's got FiO2s chosen. So I can set my FiO2, and ultimately I have two 50 psi sources of air and oxygen. I can precisely set an FiO2 by turning this knob appropriately, and then everything that comes out of here is 50 psi, all right, at whatever FiO2 I have set. So you could hook this up to a ventilator if we wanted to, but we don't need to anymore. What I have here is a couple of other fittings, and I had this hooked to a high flow meter. So you can't really see very well in this video, but my high flow meter, this goes up to 75 liters a minute, all right? Traditionally in practice, we're not going to go up that high. We'd maybe go to 60, and that would be the uppermost limit and everything like that, okay? But this gives us the ability to set flow and FiO2 separately. Now, this flow meter looks a little bit different. As you can see, I have what's called a muffle adapter or a muffler on here. It makes 60 liters sound not quite as violently loud as if I didn't have this, okay? So I have several of these, but that ultimately just threads onto the disc diameter, or the disc adapter on the end of the flow meter there. Okay, so as we get in, my tubing's pulling me further away, hang on. As we get into this stuff, as we start really getting into more of our advanced devices, and this is not an advanced device, but it is compared to all the other stuff we've been talking about, I want to filter this gas coming out of this thing, okay? So I typically am going to use this is a simple bacteria filter, all right? It's got the correct diameter on one side and not the other, so if you hook it up and go, oh, it doesn't fit, just switch it around, and then it'll slide right on there. That just makes sure that nothing funky is coming out of the system, and it's going to filter the gas before it goes to our patient. Now, we're going to use this as, you could consider it a true high-flow cannula, but there's a bunch of different interfaces we're going to set up with, okay? So you'll notice that I couldn't hook regular oxygen tubing up right like that there. I have that 22 millimeter outer diameter on this piece. So this is going to use kind of large bore tubing, okay? What we're actually going to use on this is something called a heated wire circuit. I'll show you this a little bit better in class. All right, but as you open up a heated wire circuit, and they actually do make circuits just for Optiflows themselves. Okay, mine is just I'm stealing parts from a ventilator circuit. This short tube is what we use to take gas from the gas outlet of whatever device we're using, and then run this to a simple passover humidifier. Okay, so this itself is not heated, but it takes gas to the heat source. Okay, so I'm going to simply put that piece on right like this. So once again, 22 millimeter internal diameter. It's going to hook up that 22 millimeter outer diameter on that bacteria filter. Voila, something like that here, okay? So what I have down here is a MR850 heater, so it's pretty standard. This is just a hot plate if you think about it like that. This is a simple auto feed or gravity feed passover humidifier, okay? So as you get a fresh one of these, and I'll do this in the airboat video, it comes with everything kind of sealed up. You pull this blue piece of plastic off, and then that maintains the sterility in this. So we do it right before we hooked it up. I've been using this one for a little while, so we'll kind of go with this. It does not matter which side gas goes in and gas goes out. Gas is going to go in one side and not the other, just pass over. If you look inside, there's a big piece of plastic. That's that auto feed or the float that maintains a water level. This right here is our water bag or our spike. Okay, so this would pull out of this particular piece right here. It comes all wrapped and coiled. And we're going to spike this into a bag of sterile water for inhalation. I'll show you in a little bit. I've been running this with a ventilator, and I got mine kind of knotted, so it's not going to work. So I'll kind of talk about it from a perspective, but I'll show you on the airboat video. I would take this device that's sterile. There's a little blue piece on the hot plate right here that just kind of keeps everything together. All right, I'm going to go ahead and push down. I'm going to slide it, push it until it clicks, and then it's all good to go. All right, I'm going to take this tubing. I'm going to hook it just on one side of the passover. Okay, gas is going to go in. It's going to go over the surface of that hot water. It's going to become saturated, hopefully 100% saturated with that water content. All right, it's going to heat this up to 37 degrees, and I'll show you how that kind of works here in a second. And then gas that is conditioned or properly humidified is going to come out of the gas outlet right here on the other side of the passover. Okay, so at this point, I could take this spike and I shove it into a bag of sterile water. Okay, since I got this tied up, I'm not going to, but I'll just show you. You got to be careful you grab sterile water. Okay, you don't want to grab like potassium chloride or something else. Not that it's going to kill the patient or anything, but it's less than ideal. If we use like sodium chloride, it's not going to hurt the patient, but it's going to kind of make some deposits and stuff on the inside of this. So you got a sterile bag of water. It comes with a little protector or a little seal and stopper on here. You twist that off. It'd still be sealed. You would take that spike and ram that thing home. All right, you got to be careful. I've had it where they shoot out the side and you get a big leak and you get a new bag. So put it in nice and snug. And then as you lift this up, it's going to gravity fill, and it's going to automatically inflate that until that float goes up and that closes off a valve. Sometimes if you're having trouble, there is a little piece on the side of this here that you can open up, and it can make it makes it like an intentional brief leak in the system to allow that water to kind of drain a little bit faster, but I typically don't have to use something like that. All right, so I would take my bag and I would hook this. I got spots up here. It does need to be higher than the system so it can use gravity. I got little clips up here that we can kind of do our thing with that. Let me show you the other line of this inspiratory heated wire circuit. Okay, so they do make, once again, Optiflow makes circuits where it just comes with this. I'm stealing mine out of a heated wire circuit for a ventilator. But you can see there's a side that's got this little blue piece right here that's going to accept what's called a temperature probe here in a second, which monitors the temperature of the gas going to that patient. All right, and then what we have on this side, this is going to be the side that actually clips on to the top of the passover. I got a spot that I'm going to hook up electrical charge on the back side of this circuit to energize and heat this circuit so I can, my passover is getting that gas conditioned to 100% saturation at 37 degrees Celsius or body temperature. This energy source is going to electrify, and if you look inside of the circuit, there's a little electrical wire. It's going to maintain that temperature so we don't get condensation, and we can deliver that true 37-degree conditioned gas to our patient. So this side needs to go on top of the passover. So electrical coils here, or the pigtail that I'm going to plug in, I'll show you that here in a second. And then you got another spot that accepts another piece of the temperature probe that monitors the temperature of the gas coming out of the top of the MR850 passover. I'm going to simply put it on just like that, okay? So now I can set my flow rate. It would pass gas all the way through here. It's going to get it conditioned. It's going to come through here, and then I could hook up a variety of interfaces that I'll show you here in a second. Let's talk about temperature probes and pigtails here really quick, okay? So with this heated wire system, or this kind of servo-controlled unit, meaning it has the ability to kind of measure what's happening in a certain place and then change kind of what it's doing back here at the heater, it's able to kind of constantly get feedback and make adjustments to maintain this constant 37 degrees. So with this, and usually these would be hooked to your heater, just kind of showing you what takes place. This is called our pigtails. Okay, so this is what actually gives electricity to the heated wire circuit to heat that up and maintain that temperature. So you can see it's got the little yellow piece here. If you look on the side of our heater, it is color coded. I'm going to slide this right in. You're going to, if it doesn't go in, just kind of keep twisting, and then you got to get these grooves lined up, push until it clicks and won't come out. This is for typically our inspiratory line, or these blue ones in the heated wire circuit. It's got a shorter piece that is typically for the expiratory. Oh, I got that backwards. I'm sorry. Not thinking clearly. Trying to get this video done before my other lab. All right, so this one, this longer one that's only got, pull it up really close. All right, you see it's got two little prongs versus this one is like a triple, and you'll see better when I get a person. Let me show you here. You can see it's got three. All right, that is going to hook up this. The short one is going to hook up right into the back side of that inspiratory line, or that gas line going to the patient. Okay, and that's going to charge it. We can leave this one hang on the Optiflow. This long two-pronged one is for the expiratory side of we get into heated wire ventilator circuits where we have an inspiratory and expiratory. It prevents that expiratory gas from having condensation problems. The beauty is you cannot hook these things up wrong. If you look, there'd be 3 holes on the back of this. There'd be only 2 on the expiratory side, and we'll get into that as we get into ventilators. So we can leave that one hang. Once again, that's energizing the circuit. And I have a temperature probe. Okay, so this is a blue adapter. It's got a spot that's going to go into the top of that, right above that MR850 passive rehumidifier. All right, and measure the temperature of the gas coming out. And then it's going to measure the temperature of the gas right there close to the patient. So just proximal to whatever interface we hook up. Once again, color-coded. I find the blue hole over here, stick it in. All right, so this first spot, you're going to take this little cap off. Okay, there's a little wedge that kind of keeps everything locked in place, and you'll be able to see it. All right, but we're going to push this through, and we're going to push it until it clicks, and it keeps it in place. So what this is doing, all right, it's measuring the temperature of the gas coming out of the top of this thing, and it can tell the heater, hey, I'm too hot or too cold. So it's letting it know how hot the temperature is coming out, and it can adjust the temperature as needed. We're going to take this line, the longer one, and we're going to open up this little blue port. This is the temperature probe. So it measures the temperature right before that gas goes to the patient. Okay, so this one back here is telling the heater what it needs to do. The temperature probe here is telling the heater what it needs to do in regards to maintaining the temperature of this inspiratory line for our patient. Okay, so this is what is going to measure what's going to the patient, and it's going to condition that gas, keep that gas conditioned by adjusting the charge inside of this thing. You got to be very careful about these getting wet. You also got to be very careful about fans blowing on it, because it can kind of mess up your measurements and trick the system. This cord gets easily tangled. You see there's white clips on here. I take that temperature probe line and kind of clip it in place, and it prevents it from getting kind of hung up on a bed rail. It's just so goofy that I got to kind of squat down and do this. All right, so I'm going to go ahead and plug in my heater. All right, so there's a power button down here, okay? There's an option to silence alarms on this left-hand side, and there's graphics that kind of show you all this stuff. And then there's a choosing between invasive and non-invasive. Ultimately, there's preset temperature settings on here. Invasive is 37 degrees, so even though we're typically going to be applying this to the upper airways, it's such a high flow that we're using, we try and keep it on 37, all right, to kind of prevent any sort of drying effect on the airways or anything like that. And it does make it a little bit more comfortable. Some of your patients may not tolerate that heat, and they might ask you to cool it down. I go back and forth. If it's what it takes to keep them wearing it, that's great, but ideally you run these at 37 degrees. So I'm going to go ahead and turn this on. All right, once again, I should have my water bag hooked up. I got a knot tied in this one. This is going to show us the actual temperature. Okay, so it's 23.1. As I start cranking flow through this thing, all right, you'd see our measurements start adjusting. What it's going to start doing, it's going to realize, because I got on this invasive setting here, you can't really see, starts out, it shows the invasive or non-invasive down low. It's going to realize the temperature is low. It's going to start heating this up a little bit more. That'll get that water hotter, and it's going to maintain a better temperature here. And then the ventilator will be making sure that the temperature between here and here stays the same by adjusting the electrical charge. So it takes a little bit of time. If you were going to do non-invasive, and we do, like if we're running heated wire with a BiPAP or mask ventilation, and we'll get into an RC150, you can press and hold this button, and it'll switch to non-invasive, okay? There is a way to jailbreak these things and change the setting, the temperatures, but invasive is usually 37, and that's pretty standard. There's a couple of times we'll talk about where you could go up higher, like inhalation burns and stuff like that. And then low is 32, or non-invasive is lower at 32, okay? So we're going to put it on invasive. You can see I'm warming up. It's never going to it's going to be problematic, and I'm not going to fully get there, and I get alarms, and it's the most annoying alarm you ever hear. All right, just because I don't have water in this thing. So I'm going to go ahead and turn it off by pressing, kind of holding it until it clicks. I'm going to turn off my flow for a second, and I'm going to show you a couple of different interfaces with this. And then I got to go. I got my students to be showing up here in a second, okay? So with this, hang on one second. We're going to typically use this with prongs, okay? So it looks like a nasal cannula. You can see the curve should shoot back up into your nares. It's got a nice elastic strap. And then what we have, this has got that 22 millimeter outer, 22 millimeter inner. Voila, they connect like this, okay? So I'm going to hook it up on Fred here. Hang on a second. Hey, Fred. Okay, so I'll talk about what this strap is here in a second, but it ultimately keeps some of that tension off. We're going to go ahead and we're going to kind of slip this through. They do make small, medium, and large nostril or large prongs. Typically, we want to try and occupy at least 50% of the diameter of the nares, and that's going to make a good, not a good seal, but it's going to generate, as we put in a lot of flow into a closed space, you're more likely to generate a little bit of upper airway positive pressure that can kind of help some of our patients in regards to not just fixing their oxygenation, but sometimes kind of help them with their breathing a little bit, okay? Very, very little. This is mainly an oxygenation device, okay? But it does generate a little bit of positive pressure, and it can kind of get us where we need to get to. So you can tighten that up a little bit. All right, we don't want all this circuit kind of hanging on Fred, so we can run this little neck lanyard around him. It's a little tight on him. Okay, and I could just kind of loosen it up, and then that keeps it from falling out of his nares and everything like that. You can see these are a lot more flexible and kind of soft, so you want to make sure they're not kinked or anything. It's hard to get them into Fred. So once again, small, medium, large. Majority of our adult patients, I'll say with a large or a medium. Very seldom do you have to use the small there. As we get into some of the more trademark stuff, they do make some that are color-coded as far as the size, so you can really tell. Otherwise, very difficult to say, is this a small, medium, or large without kind of looking at the prongs and stuff. So the color-coded scheme that they have with the Airvo, and we could hook up with this, makes it a lot more evident to kind of tell what's going on. Obviously, Fred's got a trach, so we wouldn't really put him on this. I'm just kind of showing you, okay? So the prongs is kind of the best, or the most common way where you're going to use this. All right? If you can't get your machine to the other side, you can take these prongs off and have it where this line comes from the left rather than the right. You just got to be careful you make a good seal, and we'll kind of play with that in class a little bit. Let me show you some other stuff we could do. So we could also do a trach collar. Okay, if you want to do a trach collar, you could. All of our aerosol devices or airway type appliances have that 22 millimeter outer diameter. That's going to hook on right like this. Okay, we go ahead. We can put that trach collar on old Fred here. Okay, and keep in mind I don't have my flow going right now. I'm just kind of showing you some stuff. They do make. Sorry. Forgot some of my stuff here. They do make a little airway scoop, so if you didn't want to actually put that trach collar on him, or I've had people before where they get like a radical neck surgery and they don't want anything hanging around their neck and messing with their cuts or drains or incisions or anything like that. Let me kind of show you what I have here. Hold on, I just broke it. They do make a direct attachment. Hang on. They make a direct attachment like this, okay? Airways have a 15 millimeter external diameter attachment, whether it's an ET tube or a trach, it doesn't matter what size trach. Most of our airways have that 15 millimeter attachment. This is that 15 millimeter ID. This is 15 millimeter OD. Hooks on right onto that trach like this, and then we could hook up, okay? You don't even so much need this to keep anything from hanging. All right, I typically would just try and support this circuit and make sure that it's not, draining in him or pulling on his neck or anything like that. So that's another one you can kind of see. Let me show you my tried and true favorite when we're dealing with a trach patient. And then I'll introduce one last measure for safety, and then we'll call it a wrap. I'll do my Airvo video after my other lab here. Okay, so this is what we call an inline suction catheter. Okay, it's got the ability to go down and suction out an airway without having to break the circuit and maintain, wear sterile gloves and all this stuff. This is commonly what we use on our ventilated patients. Well, trachs, we got to go down and suction these things out, okay? So open suction, as you guys will find, is kind of cumbersome, takes some steps, people are less likely to do it. Inline suction, so this thing's got that 15 millimeter internal diameter, can go straight onto the trach here, okay? This has got a piece of corrugated tubing, which is going to, I need one more adapter here to kind of hook this piece up or whatever, but I could kind of hook on like this if I wanted to have something. A lot of times I'd still use this flex tube and I just need one other little piece, okay, that can allow me to hook two 22 millimeter adapters together. Well, the problem here is this is set up for a closed system, meaning ventilator. We're trying to push all the air into the lungs and then out of the lungs back through the ventilator. If I hook this on Fred here, he could potentially have no way to exhale and we could run into problems, okay? So what we need to do is take that end piece off, use our corrugated tubing, and once again, I still kind of like a piece of flex tubing, depending on how far this is away from our patient, so it's not pulling on their trach so much. Now I got a way for them to exhale, and I don't create a positive pressure too much and hurt him and pop his lungs or anything like that. So I could use this as a T-piece, and then I have the ability to go down and suction out his trach. If anything happens, suck stuff out, okay? So because bad things have happened with these devices, and this is something respiratory departments are making, they do make a trademarked one that's got a digital blender, and it's a little bit better than this one, okay? On the PD side of things, we have pressure pop-offs to prevent any sort of excessive pressure from building in the system. We don't have that for the adult stuff, so if I put this on, forgot to take my cap off, Fred, if his airway was inflated, the little balloon on the end of that trach, all that air going to his lungs, he'd have nowhere to exhale, 50 psi, keep cranking through. Fred would eventually end up with 2 pneumothorax and die. Okay, so you shouldn't have to think about making sure you got an open system, they have a place to exhale. But as we start getting into placing devices on patients, especially at artificial airway, you need to think about how does gas go to my patient and how does gas get out of my patient. Exhalation is paramount for survival, all right? So just in the event that you forgot something or something happened and it got plugged, okay, one thing, and this is kind of rigged up, you can build your own little pressure pop-off. So this is what's called an external PEEP valve. So it's a spring-loaded valve that traps pressure in a system, and once it gets above a certain level, it allows it to go out. It's very, very simple. There's a number on the side, and you just dial it down and put more tension or less tension on the spring. We have what's called a Y adapter. It allows us to Y 2 corrugated tubing sources into one, okay? I got a couple little adapters, and I rigged this up here. It's got a 22 millimeter inner that goes onto there. I'm gonna put my PEEP valve on. Okay, I'm gonna put this so I can get everything hooked up. If you look, this will hook on right like this, but then this is not going to go onto my heater. I'm gonna use this other little adapter and get this hooked up. And let me kind of show you what happens if I don't have this adapter. Okay, I'm going to plug this end here. I'm going to crank up my flow. Got it going at 60. You can see that tubing is about ready to explode, right? You see it moving? Imagine that inflating in the lungs. It'd be a major, major problem, okay? I put my little valve on here, my little pressure pop-off. If 20 centimeters of water pressure builds in the circuit, it creates a safety vent so nothing bad happens to my patient, okay? So if you ever come in and hear that, and that could be condensation, or it could be you forgot to put that ability to exhale on a T-piece. You hear that, you know, something bad's happening. Once again, this isn't FDA approved or anything like that. This is kind of rigged up, but I know this was kind of what we did at Mercy a whole lot. But there are commercial devices that have some of this stuff kind of built in. This particular blender, okay, is not digital or anything like that, so we would really need to add on the ability to make sure the FiO2 coming out of it is correct. Ideally, real-time monitoring would be great, but a lot of times we'll spot check it during an initial setup and then kind of leave it be. But I have had blenders go bad on people. We didn't know what's going on, and come to find out the blender was faulty. So I'm going to show you the Airvo here in a little bit. It eliminates some of those problems, but it is a little bit more complicated to run. The great thing about this is you can directly change the FiO2. can directly change the flow. And we'll talk about good starting points, but most of the patients we're going to leave on 60 liters a minute until we can wean that FiO2 down to something good and low, 40% or something like that, and then try and transition to a different device. And kind of go from there. It depends on the patient. Okay, the Airvo is not as intuitive, but once again, it does have some additional safety features, and it's easier to kind of transport a patient on and everything like that. So I'll kind of show you that in another video, and we'll play with this in lab. This is just meant for something you can kind of go back through. It's the first of many involved setups, but it's really not that bad once you get used to it. But just kind of so you have an ability to kind of go back and look over some of this stuff. I'll catch you guys later.